If thickness drifts by just 0.05 millimeters, the steel tears at 1,800 meters per minute, destroying a 20-ton coil in seconds. Here's how steel becomes a 0.8 millimeter sheet inside a cold rolling mill running at highway speed. This is where precision becomes survival. This is where thickness control fails. Cold rolling reduces steel thickness by up to 80%, while holding flatness within 0.5 millimeters per meter. If any tolerance slips, force, tension, temperature, chemistry, the entire coil fails downstream. Today, pickling, tandem rolling, annealing, temper rolling, final QC. Modern AGC corrects roll gap to plus or minus 0.02 millimeters every millisecond. Before steel can face 2,000-ton rolling loads, its surface must be flawless. Hot-rolled coils carry a millimeter-thick oxide layer. Pickling dissolves it at 80 to 90 degrees Celsius, using 15 to 20% hydrochloric or sulfuric acid. pH sensors hold the bath chemistry to plus or minus 0.3 pH units. If pH drifts beyond that window, micro-pitting forms, and the strip rips in the first stand. Acid is filtered and recycled. Iron oxide becomes cement feed. Line speed, 20 to 40 meters per minute. Clean steel isn't optional. It's a prerequisite for deformation. The strip is about to face forces that would snap untreated steel. This is where tension will start to build. Now the strip faces the first real threat. Force. 6 stands apply 2,000 to 2,500 tons each. Speed climbs to 1,200 to 1,800 meters per minute. Each stand reduces thickness by 15 to 30%, targeting 0.8 millimeters final gauge. AGC reads thickness every millisecond using X-ray or laser gauges. Hydraulic actuators correct roll gap within plus or minus 0.02 millimeters instantly. Water cooling prevents roll thermal expansion. Interstand tension keeps the strip stable. If interstand tension drops more than 3%, the strip buckles, and no downstream stand can recover it. Steel remembers every pass. Uneven force creates waves that destroy flatness before annealing. Since the 1980s, AGC replaced manual screw downs, cutting thickness variation by 70%. Here, tension decides survival. The strip is thin, but too brittle to use. Cold-worked steel is hard and unstable. Annealing heats it to 650 to 750 degrees Celsius, 1,202 to 1,382 degrees Fahrenheit, for 4 to 8 hours, allowing grains to recrystallize. Thermocouples track multiple zones. PID loops hold uniformity to plus or minus 5 degrees Celsius, plus or minus 9 degrees Fahrenheit. If temperature exceeds 760 degrees Celsius, grains grow. If below 640 degrees Celsius, recrystallization fails. Both cause cracking during stamping. Controlled cooling prevents thermal shock and preserves structure. Inside the furnace, the metal is soft, but unstable. Heat corrects what force distorted. So far, scale removed, thickness reduced, and ductility restored. Even after annealing, the strip hides microwaves. The temper mill applies 1 to 3% reduction. Flatness tolerance, plus or minus 0.5 millimeters per meter. Laser profilometers scan every 10 millimeters. Roll bending actuators respond within 200 milliseconds. If flatness exceeds plus or minus 0.8 millimeters per meter, downstream stamping tools fracture. Flatness is geometry, and geometry decides part quality. This is where cosmetic defects become structural. The strip looks perfect, but the meters of data decide its fate. Final coils weigh 15 to 25 tons and span 1,000 to 2,000 meters. Ultrasonic gauges verify thickness. Laser profilometers confirm flatness. Visual inspection identifies surface defects. One bad reading means full coil rejection. One digit decides everything. AGC samples thickness every millisecond. Interstand tension loops update 200 times per second. Roll bending actuators correct crown within 80 milliseconds. Oil film thickness sensors prevent roll welding. Chatter monitors detect third octave vibration and retune tension in real time. The entire grid keeps 1,800 meters per minute steel stable. Stability is not natural, it's enforced. Closed loop control spans force, tension, bending, and vibration. From oxide-coated hot roll to 0.8 millimeter steel, the entire line holds tolerances tighter than a human hair. Precision isn't a feature, it's the only way the strip survives. If you want the next deep dive, maybe how galvanizing lines coat steel at 450 degrees Celsius, just tell me in the comments.